We're all here. Who's missing? Dan also, right? Yeah. Let's wait for you. Anyway, how many managed to proceed to the last step? Step 4. Step 3. Step 2. Step 1. It's okay. It's fine. I think we will have this opportunity to review what Nextflow is, what it's capable of doing, and how we can perform each of these steps in a Nextflow script. So the task was to replicate this simple RNA-seq workflow. So I will engage you. So I will want to hear what you guys did. So the workflow basically performs indexing of a transcriptome file consisting of transcripts. It's in FASTA format. It performs quality controls. It performs quantification. So you have some raw reads which you need to quantify in terms of the transcript abundance, and then create a multi-QC report. So the first thing we did was we were categorical for us to do it on our machines, either on HPC or on our computers. So we were cloning the training repository into a local machine. Using this command. So once we did that, we were in a position to proceed on with the rest of the workflow. And the workflow depends on a couple of tools or software which are needed for it to run successfully. So one of them is Salmon, which is a tool for quantifying molecules known as transcripts through a type of data called RNA-seq data. FastQC performs quality control and multi-QC, which gives a report on, it gives a summary report on the outputs from the different tools that we often use. Okay. So now, who can tell me how we can go about having these tools installed on our wherever we're working, be it on HPC or on your local computer? How did you ensure that you had these tools?
Ensure that you had a Linux system.
Exactly, yeah. Conda. You could install them using Conda. So how did you install them?
Environment, then they install Conda, Salmon,
Yeah, that's one way of installing it. But if you are keen enough, when you clone the repository, there was this end.yaml file which had all the dependencies required. So if you look at it, it's just a configuration file telling Conda that if you want to create the environment, let it be called NFCO tutorial, and these are the channels in this order, and then the dependencies of the software that we need are given here. So each with a specific version. So how you install that is just Conda environment create, and then you give it the name of the environmental file, and you'd have all those installed locally.
Sorry, what if I wanted to change the name of that environment from there?
It's possible.
Directly from there?
Yeah, it's possible to change the name of the file.
Of the environment.
The environment, yes, it is possible. So how you do that is just edit it and maybe give it a name that you want, maybe RNA-seq or
might option -n also change it, override that, but you know.
Conda environment creates -n.
-n.
Yeah.
Like you override that.
Yeah.
I
Maybe.
think so. I don't know, but you can try.
Yeah.
It should.
It should. So yeah, that's one way you could do it. Edit it in there, or as you say, Conda Conda environment create. Let me see the options it has. So it requires based on an environmental file. Yeah, the name of the environment. Maybe it can override. It can override. Yeah. Yeah, actually, you see, yeah. Yeah, it can override that, I assume. So that's one way you can do it. But also the other way would be to, if you were to run this pipeline without using Conda, you would use a different way. How would you achieve that? Hmm? Yeah, if you have Docker installed, you can just invoke it with Docker, so that that will pull the Docker image from the repo and then install all those softwares and then be able to still run it. But I realized this was taking a longer time for some of us. Okay, then we go into the nitty-gritty. So we'll just review what they have put here and try to put our heads together in order to understand the steps, whatever is happening in each of these scripts. So the first script had these lines. So Nextflow has a keyword called params, which specifies parameter, or specifies the argument or the options required for a particular parameter. So for instance here, we are defining that there is a parameter called reads, and we specify the path where those reads are. And what we see here is that these are enclosed in quotes, but also what we see is that we can use, how do you call this, pattern matching or regular expressions to denote which files we want. So we want files that have the name GAT, an underscore, and they can be either 1 or 2. They can either have 1 or 2 in the file names and end with FQ. So Nextflow is able to utilize this pattern recognition using wildcards, as we will see later on. But also you can explicitly specify the type of files you want using the naming convention of your files. So if you had, for instance, GAT underscore R1 and underscore R2, this would change accordingly. Yeah, the other keyword that is in Nextflow is this project dir. So this is a keyword that specifies that the workflow is running in your current in your current directory. So you can specify the name of that directory using project dir. And similar to shell or bash scripting, this keyword or this variable is preceded by a dollar symbol. So for you to print, for instance, in Nextflow, you use a keyword called println, and that will print, for instance, reads, and then it will look at the variable here, params.reads, and print that. So similar to shell scripting, this is a variable, and it has to be preceded by the $sign. Now, this was hard-coded in this script one. What if you had a different path to a different set of reads or files? Because we've already indicated that there's a parameter called reads, we can use that as an argument or as an option for your script. So what you'd simply do, similar to what you do in Python or any scripting language that requires some kind of arguments to be passed, you invoke or you call that argument using this double dash and the name of the parameter. So the parameter here is reads and specify a different path. Normally it's advisable to specify the whole path and in quotes, and then still use the pattern matching method to identify which files you want to work on. Now the first task here was to add a fourth parameter named outDir and set it to a default path that will be used. So how can we achieve that? In script one, we want to add another parameter called outDir.
I think we just below the params must to see. So you write dir equals to the name you want to write, either out directory or result or whatever.
Okay, so let's try and do it differently. I'll call it how should I call it? Script. I don't have 8. Yeah, script 8 dot. So all Nextflow scripts will have the extension .nf. So the other thing is that you can always use this line to indicate that the interpreter is Nextflow. And then we want this to be DSL2 enabled. Nextflow.enable DSL2. Okay, so that the syntax and the functionalities of DSL2 can be applied in our script. So the first one was params reads. I don't know if I should do this or it will take much time, but as you say rightly, we can easily say that we want this to be in our project directory and then give it a name. So if it's not existing, Nextflow will create it. Okay. Yeah, for the rest, I think I'll just copy here. Something of that sort. So we can try and execute this. Let's see what it does. Yeah, so it's what we've required it to do is just print this line starting with reads and the parameters of the reads. So Nextflow has expanded. If you look at this, Nextflow has expanded this path. Yeah, so it has given me the full path of where those reads are. So if you look at what it prints, is a full path to where those reads are located. Now, once we are done with that, so if I want to change this, if I want to change my reads, the location, I know I have a parameter called reads, so I can easily use that as an argument or as an option. And maybe use data, digital, and then now I want to use a wildcard here and say I want all the files with _1 or 2 dot fq, and this always has to be in quotes. Okay. Yeah, it has not expanded it as we were expecting, but once we get to the also you have something.
I'm just wondering if I'm curious why it hasn't expanded. Is it because of the
Because of I think it's because of I've given it the relative path. I think so. If I had given it the full path, probably it would have. The other one was trainings. Yeah, but it will still work. It doesn't matter, provided you put it in quotes, then it should be able to work. And training. Yeah, it should be. I think it's because of the relative nature of the path. Yeah. So once we have done that, we have appended this parameter. Now we want to add this multi-line string. It's a way of modifying how our lines look like. We can do it here. So the multi-line will always begin, the log info will always begin with that. So let's start with sure whether this is gonna work, but it's just going to log in all these details into a multi-line. It's more or less, I mean, you could still implement it using this print line, but let's make use of that. and see whether it's gonna run. So it's just going to print all those parameters into several lines, with something which you could still achieve with the print ln. So you could still do the same for the other parameters.
The beauty of it, though, I noticed that it takes the log file also, it prints it out to the log file also.
Yeah. So you can easily format this because you've put the quotes, you can easily format this according to your simple pipeline, and then add some fancy stuff. Oops, there is an error. Oh, can someone spot it? Tell me the mistake I did. The hash. So how do we comment in Nextflow? Huh?
Stop.
Comment?
Forward slash. Okay.
Like this?
And if you
Smart
line
line.
on the
Simple
it's a
line
mar-
would be
Yeah, so for single line, you just put, yeah, if it's multi-line a block, then you use / star, and then end with a star. Yeah. That's because it's a single line. Or do you prefer? I mean, it also it's preference. It depends with your preference.
as many as
Huh?
so in each line you just have the double slashes as you go.
Yeah.
So I wanted to ask what's the significance of the log file or the log info? It's just for your own information purposes.
Yeah, just
Yeah.
telling you the details of what your pipeline is, what the inputs are, what the parameters are. Yeah. But
in essence, it doesn't affect you.
Yeah, it doesn't affect your code. It's just printing what. Yeah. But if you're going to write advanced pipelines, then I think it's able to you're able to achieve that using what we will look at later on, if time allows, Nextflow tools. Yeah, it's just a way of formatting or printing whatever appears on your screen. Okay, so you can still use a placeholder. You can use as I said, the syntax for a variable follows that of shells, so you can use the $, the variable name, or the $, in placeholders, these curly braces. Okay. Now the first process is to create a transcriptome index. So this process takes in a file in FASTA format, and then provide and then process the file to produce an index. So normally when you've done RNA sequencing, you are at times interested in quantifying the transcript abundance in that in any sample that you have sequenced. So most of the time people use Salmon to achieve that. So the first step you need to do is index that transcriptome, and then later on we will quantify the abundance of our transcripts. So as I said yesterday, to write I mean, all these steps in a workflow are basically stages or processes that you stitch together to form a workflow. And the basic syntax of a process, we said, the keyword process, then you give it a name, I see most of the time people who write Nextflow pipelines, they prefer capital letters to name their processes. And then, what was the first thing? Yeah, we need the input. And here, what's our input?
It's actually transcriptome file.
And we said it's in form of a channel. So a channel can be a value, path. So what type of channel is it? It's a path, right? And then the name of the channel, transcriptome. And the next one is output. What's the nature of the path of the channel? So Salmon will create an index, but what would be the output of that index? It will have several files, but we want this to be
Path.
Yeah. Right? Now we will hard code this to ensure that Salmon index, and then what was the other component?
So what does that new Salmon index?
So it's in quotes because we know that we want to create a directory, a channel comprising of a directory, so a path to a directory called Salmon index. We don't have it, but Salmon will create it. Yeah. So what was the other thing? And scripts are, just like a shell script, but you have to enclose this, okay, in triple quotes, because remember our interpreter up there is an Nextflow interpreter, but the script you're running here is a shell script. So
Does it matter if you have a space before, or it can just be in your within nested within the quotes?
here,
No, like in the, it's like
in here,
no, you've seen the way you have put a space after.
after
Does it
the
matter? Or as long as it's nested within the
a space after there,
oh, there's no space.
there's no space.
Oh,
I just entered it in a new line. Yeah. So what's the syntax for this Salmon thing? Threads. And here we can make use of internal parameters that Nextflow offers. So Nextflow is able to have this variable called task.cpus, which will identify the number of CPUs. What else?
So it will run by itself.
Yes, it will identify by itself. So we will run this and look how many threads it has used.
Alternatively, you can supply.
Yeah, you can supply a value which you can put in there's a segment up here we call the directives. Yeah, so you just specify CPUs, maybe use 1. Okay. And then the process will look at this directive and know that I need only 1 CPU. Okay. What was the other thing? Yeah?
Input minus T.
Minus T, the transcriptome file, which is
Input channel.
transcriptome. And then which other option? Where we want output, the name of the index, which now should be Should it be in that way, or should it have a dollar sign?
It doesn't.
It doesn't, because we have explicitly put it here.
Yeah, it's not really.
Yeah.
It's not a channel.
It's to be clear.
Yeah. Any other option? That's fine. Okay, then now we want to execute this as part of a workflow. So Nextflow will have the keyword workflow, which still has the capability now of running the individual processes or steps that we indicate up here. So what's the process that we want to execute in the workflow?
This
Index, and what does it take in?
For the channel, the transcript.
Yeah. So you can either, yes?
I think we give the path to the transcriptome.
Yes, the path to the transcriptome, which we earlier on defined here. So if we were using a different transcriptome file, in the command line we would have used -- transcriptome. Okay. Rams dot transcriptome. Is it transcriptome or transcriptome file?
Transcriptome.
Yeah. Let's see if this is gonna run. So what is it? What is going to be the output for this?
Are you supposed to put the dollar sign before the client? Oh,
Tell me why we. Are we? So Davis is asking why we are not putting the dollar sign here.
Because
Can
it's
someone try?
I think because it's not within the script, it's outside.
Yeah.
It's within the Nextflow code itself.
Exactly.
I thought so, but I also was wondering why in the info part they can use the dollar sign.
In there?
In the log info.
I think that's because it's within quotes, so it's like you're having a string, but then you want to declare that you have a variable within a string.
Yeah.
Oh, that makes sense. Thank you.
Yeah. So we I hope that is clear. So now, how do we, or how should we call the output of this? It's going to be a channel, definitely, but any name can suffice because it's going to be the output channel emitted by this process. So you can give it any name. Yeah. So we can call it some index channel. So in short, I mean, most Nextflow guys they prefer using _ch to refer to a channel. Okay. So let's run this and see. I'll activate my environment because I know I need to use I didn't install it. Sounds like I don't have it.
maybe we use the RNA-seq.
Huh? Yeah. I think I was working on the HPC, that's why. So I'll try to install it from here, but yeah, it's gonna take time. It's gonna take time.
Mamba. Maybe just
Reinstall.
just go through.
Hmm?
Just go through.
Anyway, so we in script one we have something of this sort. So we are able to clearly see the different sections of a process in Nextflow. So it should have the keyword process, the name of that process, the input given in form of a channel, either as a path or a value, the output similar, and the script that is going to be executed.
Excuse me.
Yeah.
So on the inside the process, there's input, output.
Mm-hmm.
Then after input, it can be a value or it can be a file. So how can I determine if you use a value or a file?
That's a very good question. So most often you will have to probably run the tool to see the kind of output it generates, right? So based on that, you are able to already know what type of channel should I use. Yeah, it's a very tricky balance, but of course you can fine tune this to your use case. There are people who, instead of emitting this channel as a path, they want to emit the individual files given by the tool itself. So you will realize that Salmon Index produces a couple of files. So in here, you can output several of these. Yeah. But for the next process, because we are only interested in giving the path to that index, then we only need to output that as a channel. Yeah.
Okay, so like you have the name transcriptor. Is that
So this is the name of the input channel, which is referring to the transcriptor file. Although we have not explicitly stated or defined it here, you could have created a file. Let me see. I want to zoom in here. Or is it I need to zoom in?
Control shift mouse. Little mouse.
On this. Yeah?
view?
Uh-huh. Yeah.
Control to the wheel.
Unajua ni MacBook. Any
Yeah, we can pick that out in Kudo.
you're seeing it? How do you want me to zoom in?
Control, then you scroll the wheel. Press control and scroll the wheel.
No, it's not working.
It's not working.
Is that Python?
Command plus is not. Ah,
Is it Python?
yes, yes.
That's good. That's how
Figuring out.
that's how I do it.
is
File.
PyCharm. Huh?
File.
Fine.
File settings. Then that. Settings there.
You don't have settings.
I think they will
Editor general.
set
Yeah.
it. The old school control that doesn't.
Control plus is not working for me.
So file. Editor general. There's something like that.
Are you doing the same? See?
Yeah, like to activate scroll. Scrolls are in PyCharm.
Is that clear somehow?
Yeah.
So this is a script 8 we were discussing about.
Maybe you use those
The variable name for the input.
For this transcriptome. So we could have defined it. We could have defined it here as a channel transcriptome channel as a file. So this is still a way of, or channel of. So these are factory settings, yeah, and then params dot transcriptome. Okay, it's still the same way. So this would put it here. It's referring to a file, a path to a file. Transcriptome. And then instead of using the params there, now as a channel. Okay.
Transcript.
Oh yeah. Transcriptome file. Transcriptome channel. Yeah, so
in there.
so this is going to be replaced by here.
It's also not that. Transcriptome channel. Or define transcriptome channel.
Next to the variable.
Transcriptome channel. Okay. So let's try. Okay. So we have salmon. Now let's try and run it. See whether we'll bump into any errors. Let's use a different. Yeah. Something to do with Java. Not find Java. How do we solve this?
You have to create Java locally.
Yeah, my installations are not working well. So, Yeah. But anyway, I know most of you are able to do this correctly. So what has changed for me is that I now define this channel by using a channel factory, using a factory channel called channel of, and then I give it the name of my parameter, the value of my parameters file. So this is going to create a channel, which now I use as the input channel for the index. Try that. The other alternative would be to use it and just define it explicitly as a file, and that should work. Okay. So yeah, the directives, we can specify the number of CPUs by including that as a directive here. So we want only one CPU to be used in the process. So this will capture this value given in the directive. Okay. Yeah. Now when it comes to the other step, I think, which was a bit problem. Alternatively, you could run it using Docker, as I mentioned previously, by invoking this with Docker, which will launch the Docker container. So I guess probably these guys have already built a Docker image for this particular workflow, which you can easily pull and run to execute the commands.
Might that be the reason it failed, or within the conda environment you don't need to add the Docker or modify the config file?
I don't need to within Conda, because I know these tools are installed on in my environment.
Okay.
I don't need to use Docker here. I know it takes time. If I run it with Docker, it will have to pull those images and yeah, transcript or let me see. Line 23. Transcript. Yeah, this will definitely take time. So the reason why I think initially I was getting this error is because I didn't enable DSL2 syntax. I had commented it out. So when I uncomment it, then it's able, I think it's trying to run, but it takes time because it's pulling the Docker image and using that to execute this process. So the other thing you notice about Nextflow is that it will create a directory called work, and this work directory will have all the output directories for every process. So like in this process that is currently running, which is indexing, there is going to be a directory called F1 inside work, and it will have these hexadecimal values. So these are not the entire values, but it's a long string of values. So if I check in work under this directory, I should be able to see the output of my index process. Now to the second task, which was about quantification. The most important thing there was for us to have a channel for the for the reads, which is our input. So in the same way, we begin another process and we call it quantification. Again here, we put our input, output, and then script. So our input here is going to be the part to which channel to. The first input is the index, so this should point to. Then the second input is a special type of channel. So it's going to be given as a tuple, having the value of the sample as a ID and the path as a path to the reads. Okay. So what this is represented as is simply, let me try and put it here. So maybe we have GAT as a sample name, and then a list having the path to those files. So we have maybe data GAT1 dot FQ, and then data GAT2 dot. So now this is going to be like the second channel here, the input channel for our reads. So what this process is going to require is the sample ID here, which is represented as a GAT. It's a tuple of values. So it's going to take the GAT as a sample ID, and then the reads is going to be the list of reads. Okay. What output are we expecting? A path. And what? So in here, because you already have this as our, so for every sample, we want to create an output directory. So we're going to use, I think, this should work out to denote every sample. And then the command should be salmon quant who knows how we run that command. It's
it's in the script.
Hmm? Yeah, so the process actually, did it complete? Yeah, it completed. But I'm wondering why it's running it. Oh, it's not running. So in here, I didn't have to install any Conda environment. How I invoked it is using the Docker. So it pulled all the images, installed the software, and it completed successfully. As I was saying, the output, you can always check in this work directory. So when you look at your work, at your project directory, there's a directory called work. So the first process was that, and as you see, when the process is running, it doesn't give you the whole name of the directory. So it just gives you maybe the first 6 digits, and when you go deeper, you're going to see the output of our process. Okay, so Salmon index has a couple of files. In other executions, if you are interested maybe in the JSON file, you would have to create a channel that specifically emits this. But because our interest is the Salmon index, the entire directory, then we emit the channel as a path, a direct path. Okay. The other thing you can notice, there are some hidden files here, which the process is able to undertake. So if you want to know the command that was running, or if you face any errors, the command is always beginning with command F1. Where's the execution? Does not store it.
Looking for the log files? Or?
Yeah, the log and the command files. It didn't store it here.
The command files are issued in the work directory?
Yes. Yeah. So I think I'm looking in there. Yeah, so if you list all, including the hidden files, you will see whether there was an error, the output, the command that was running. So you can have a look at. So the command that was running is just a simple sh script. And so you can see this is the command that was running. So it made use of one CPU and all the other arguments that are required. If there was an error or any output, it's being captured. So this is like the standard output from a Salmon indexing command. If there was any error, you could see. So this is the error when pulling the Docker image for analysis. So all that information is in that work directory. I know it's lunchtime, I'm taking much of your time, but you can see the essence of this. So what is important here is that you must be able to know how you organize your channels. I think that is critical. Once you know how you want to capture the channel, your input and output, then it makes work much easier. And if you want to view, for instance, a channel, you can just use in this case, I can just print .view, and it will show me that it is a file. So the channel for the reads would be something like this. Would be channel. Is it from lowercase? Yeah, from file. Oops, sorry. Is it lower or uppercase?
Lowercase. Yes, that one.
File pairs, and then what are we taking? The parameters, which is rams dot, and then we can set this and capture it in a closure to now give it the name of our reads, the name of our channel. So this set is going to capture the output of this channel and save it as channel.read. So what I would do here, if I want to run the quantification process, I would simply do quantification. I know I expect the Salmon. The order has to be the way you have defined them in your inputs. channel, and then this would be channel width. Okay. You could still specify this explicitly by assigning it to a variable channel from file pairs and then rams dot width. That's one way you could do it, or this way. So in this way, you don't have to assign it to this variable. You can further check if this file exists. So using a statement like
Check if it exists.
check if exists.
Not
and
comma, colon, sorry, colon true.
right in quotes, or yeah, I think so. It's going to check if these files exist, then it will return to you the channel. If they don't exist, then it will throw in an error. Yeah. So yeah, we didn't have time to go through it, but I think the tutorial is self-explanatory. You can follow it, and if you have any challenges, I'll be still working around to assist you. But ensure that you have it running, just to be sure that next year when you're meeting, you are able to implement your own workflow using your own data set. Yeah, it's just teaching all these processes together and running them. I hope that was somehow clear compared to last year. Okay. So, or do you have any questions?
Maybe a bit weird. So the script section of the code, so for example, for that part, we explicitly telling it that one of our inputs is transcriptome and the output is Salmon index. To just have been easy, we just adding the input one, considering if your input section you have multiple inputs. So rather than writing transcriptome as the input, which I feel it's redundant based on the fact that we've also, for the input section, declared what our input is.
Here. Up here.
No, down here. The input data. So
yeah, this name does not have any significance. You can change it to anything.
Yes, I understand that. So
yeah.
rather than again write the name of the after parameter t.
Yeah.
You see the way they do it in Snake. So just pick all the entries in your input section. So rather than rewriting again in transcriptome, just write the input. So it goes back to your input section
and checks
all these things.
Yeah, that's a difference.
Yeah, I felt like that would have been much easier than again rewriting all this. But again, so
yeah.
I think maybe they thought the best way to do this. So I don't know what others think.
Definitely it's true. I think that sometimes you might have more than one input with Nextflow, which allows you then to pick different inputs as part of your
script.
To specify the inputs in the scripts. You have like a database as one of the input.
Yeah.
Fast as one of the inputs, so you can just send them.
And because these are channels, you can use other transformation functionalities to, maybe at times you want to mix those channels such that you want your only read ones to be in one channel. So Nextflow gives you that ability. Maybe you want to collect all the channels and in such kind of manipulations. Yeah, but as Kibet says, in this example, because you're only using one input, but you can have several, similar to output channels, you can have several of them. Yeah. And it's not necessarily that if you have maybe different output channels, you will require all of them for the next step. So you will have to also go down transforming your channels as you move along. Yeah.
I didn't get the difference though, because it seems to me all the same with SnakeMap. I didn't
Sorry?
quite understand.
Sorry?
I didn't quite understand the point you are highlighting, because it seems all the same to me with SnakeMap. This has input and it can take several. It has an input holder that directs you to the input. So I don't know. Does it? Are you seeing that?
So you see, for instance, if you're going to specify, if we were to go on with this work, you would do something like this. I don't know how SnakeMap would achieve that, but you now see that given this channel, we have these are our reads, right? So it still does zero-based indexing, just like Python. So our first set of read 1 is going to be reads, and then index it as position 0. So that's our read 1 and read 2. So SnakeMap could somehow, I don't know how it works, but it would I know it uses some kind of expand function to achieve this. Yeah, but there's still a bit of difference between the two workflow managers. Yeah, in as much as we end up achieving the same output, but there's some kind of distinction. Yeah.
So I'm trying to construct the idea, because I was also with this confusion. So the sum of the software is like a tool.
Yes.
And is it like, and it's doing some index to the
Transcriptome file, yeah.
transcriptome file, and the software is from 1.
Oh, my friend.
We'll be slightly late, but yeah, just ask the question.
Okay.
Mm-hmm.
Okay, let me leave that. So I've seen, like, after declaring the path, there is no on the process. Yeah, let's say
The next
quantification process. There is input, and we declare the input. I think that we choose any name, but it should be relating to what we are doing.
Yeah, so these can be any name. So these are basically channels. They refer to.
Okay.
Yeah.
So you, under the path, you add other thing, which is tuple. Is the tuple a function which is inside
Yes.
Nextflow?
Yes.
Okay, so you add the tuple and
The value is the name of that tuple, or the key of that tuple.
so I was trying to understand that where you give the sample ID, the
So-
name sample ID.
So this sample ID, remember when you're creating this channel from these file pairs, it's going to generate something like this. Okay? So in here, the sample ID corresponds to the first element here. So it could be just a sample name. It doesn't have to be sample ID. Yeah, it could be sample name. And this could be your FQ. So so what the keywords in Nextflow are path, value, tuple, value, but these other ones you can easily change. So if you change that, then also here you need to change accordingly. Okay, and here if you use the FQs, then here you also change accordingly, because now these are like variables. Okay.
Oh, okay.
Can I try to highlight a bit on this, the way I try to understand it better? You see, the input, the path is the keyword. Then whatever is there is like a variable. like you're assigning the input that you're bringing to a variable, which then you use in your script down here. So that's why the name there is anything. It can be anything. Okay? You're just taking that input, whatever it is, you store it in that variable, then you can use it down there.
Yeah, so this can change. These names can change, but the keywords for Nextflow, like path, tuple, val, path, they have to be there, depending on the channel that you are working with. Okay. And if you would have formed a different type of channel and want to capture the sample ID here, you would still use something like you want to capture a tuple. You would still do a tuple val and then sample name, and then the path to your output here, which you would name accordingly as well. Yeah. Okay. So it's not cast on stone that it has to be named in a specific way. So these values are like variables as also as saved.
So it's like, let's say there's some, maybe I want to use like GTK, the tool, or maybe REST Finder. So I can use the same alignment. I can use the same process.
Yeah, you can use the same process. I mean, but it depends. What you need to know is what type of output is your tool going to produce, and what channels are you going to use for the downstream steps. So if you're going to use individual files, then you have to output the individual files. Okay? Yeah. This was a simple one. Maybe the next one may be a bit complex. You will see how these channels vary according to the complexity of your workflow or pipelines. Yeah. But just create some time, go through it and see whether you can go to the end. If you have any questions, I'm still available. Yeah. Okay, yeah, sorry for taking your time, but yeah, we can